Welcome to the Future Ready podcast from Siemens. I'm Nick Finberg, but I won't be your moderator for this episode. My colleague Connor Pike will be taking over for this recording from Hannover Messe 2026, where he sat down with Rainer Brehm, the CTO for Siemens Digital Industries and COO for our automation business, as well as David Humphrey, the Director of Research at ARC Advisory Group. In part one, Rainer and David explain the growth curves and perceived adoption of artificial intelligence in the industrial ecosystem, most notably the distinction between what a small fraction of industry leaders are working through versus the wider market. But for this episode, they dive into how businesses can start to scale their deployments. The reins are all yours, Connor.
As we're thinking about the scaling of industrial AI and SDA as well, in your research, are you seeing this important of the execution layer? Is that reflected in investment decisions or how companies are setting their priorities?
Absolutely, yes. So prior, companies were investing in analytics tools individually, in data platforms. They were hiring data scientists to help contextualize this data so that it can be meaningful to people like you and me that don't deal with disparate data every day. This is moving into investments in execution platforms, so more at the operational level, MES, maintenance management, like I talked about before. Definitely edge computing is really big. And some customers users are investing in the control platforms. Yes, SDA, software-defined or virtual controllers are coming, but some are simply upgrading their hardware to more data-friendly processors that do a better job of pre-processing data before they share it with the rest of the system.
I think this is a very important aspect of you don't need to rip out everything. And the job of vendors need to be how we safeguard the investment of our customers. And that was, for example, a very, very conscious decision what we did on, when we brought our virtual PLC. The virtual PLC, a customer can reuse the entire libraries, everything. So basically, it's our core 1500 PLC core, which we virtualized and put it now on an edge computer. You can put it on a data center, like Audi is doing it. But the asset of, all the libraries, all the programs, the asset of how an operator, as you said, they may be afraid they cannot operate anymore. They can operate because it feels the same. From their perspective, even in the background, it runs on a data center. So how we make sure that we take our customers at the hand and go step by step in that direction. Not that so now everything is new and rip it out, because then they are hesitant, yeah. But do a step, next step, and the steps need to build on each other to go in the future. I think is very important, and we see success coming there because they're digestible steps, yeah, which customers are willing to go.
And an open ecosystem seems like it would be really important to what you said about it, safeguarding your customers' investment. It seems like openness would be an important aspect of adoption.
I think now a great thing around SDA is that openness is given. And I'll give you a concrete example, though. We take our S7 1500 as a VPLC. It runs on Industrial Edge. Industrial Edge is a fully open system. It's Docker-based, so everybody who can program a Docker container or doing it via Agent or Claude Code could basically use it and deploy it. And it's using the same data infrastructure as a virtual PLC. It will can communicate with a virtual PLC. So absolutely it's open. So software defined is a beauty thing. You can combine now PLC workload with other workload. On a hardware-defined PLC, to put different workload into a PLC, it was not made for that. It was made to control a machine or a line. So it was, under this aspect, a more dedicated system. I think with SDA, the flexibility comes in, but this flexibility only really is realized if it's open. Yeah, and that is because else, if you do SDA not open, you have limited value. That's the reason we're really having that very open. It's not only openness to deploy new applications, as I said, as a Docker container. It's also open because we said we could connect to all different field levels. So it's not you need to rip anything out. You can say put the edge computing on there, and you have all different kind of systems, PLCs from all different vendors, and you can connect, get the data, and then add the value on top of it.
SDA is by definition open. The days of proprietary systems or platforms for competitive advantage, they're over. And we're learning this from the IT world as we migrate to IT-like architectures and to an IT mindset. SDA is a concept. It's not a product. I don't go out there and buy a piece of SDA. It's an idea that guides my implementation of my architecture. And I can choose to use a platform. There are lots of platforms out there. I can choose, in your case, Rainer, the Siemens Industrial Edge. It might be a nice fit with the virtual PLC, but these things can pretty much run anywhere. Openness is in, and it's here, and it's here to stay.
A little bit disagree with David. Not I'm disagreeing. I think it matters which platform you're using, because still openness is one important feature on the one side. On the other side, we talk about a deterministic real-time system. So that means, we need to build something in the system which is open, but, where you guarantee a certain determinism for an application. It cannot be you have one application and when you put another application on there and the other application will not run anymore. So take the PLC. A PLC is deterministic. So, but it's open. So we need to take care, and that we took care on Industrial Edge, for example, that you have a special core only reserved for the PLC, because you want to make sure if somebody deploys another app, the PLC still works. Right. Yeah. The same topic then goes further under the aspect of long-term availability. Because we also know, maybe in the IT world, you always get updates, and which we also need to learn from the OT world, that we need to get updates. The IT world gets updates. But how we make it long-term available. If you cannot say after 3 years, no, something new is there, rip it out, do something completely new. So also we need to make sure that the OT values are still in that platform. And we add the openness topic on top of that.
So thinking about some of these capabilities, and we're discussing the openness of flexibility as well. I'm wondering, Rainer, where are you seeing maybe the combination of industrial AI and software-defined execution? Are we already there with real-world applications, or are we still on a journey to connect those dots together more fully?
Technology-wise and product-wise, we are there.
Okay.
On the adaption, again, we come back to our initial statement, probably more on the 80-20 side, where 20% of the customers are basically working with it, and maybe only 5% have scaled it. I would put it even that way. But yes, product-wise, we are there. I mean, again, coming back to the platform we just discussed, hey, I can put a virtual PLC on Industrial Edge, and there is an app called AI Inference Server. And that's an inference server which can run even NVIDIA on NVIDIA cards on the same platform. And what you definitely can do, you can deploy an application into your PLC and deploy a trained model on the inference server, and they can communicate with others. So it's there. How many customers are really using it? That's, again, coming back to the 80-20 rule.
So then, David, as we think about the market for SDA and how it's evolving right now, how do you see the space evolving globally, and what kind of growth rates are we seeing? Are companies already restructuring their strategies around adopting SDA, or is this still more vision than reality?
It's a little bit of both. We're somewhere between vision and reality. Like we talked about before, there's early adoption. There's different phases or stages of early adoption. Where we see it is first in discrete manufacturing. The two obvious industries are electronics, because electronics manufacturing lends itself well to early adoption because we change the way we make chips. In electronics, every few years, there's always new machines being constructed. And then automotive, the Audi case has been talked about. I love talking about it. At BMW, there's stuff going on, and I'm trying to find my way in there. Yeah. I know some inroads, and they're more secretive than their Bavarian cousins. But you asked about the growth rates. So if we take as a baseline growth rates for automation hardware of not the past couple of years because they were very volatile, but typically 3 or 4%. And if we look at industry software, baseline growth rates of, let's say, 6 to 8% for mature software, we're seeing industrial edge platforms grow at rates of 15 to 25%. I would say we're projecting that growth. Right now, the growth is actually spiking because we're starting from practically zero. So you're going to get 100, 200% growth in the first couple of years, but that'll level out to like 15 or 25%. For the virtual PLC, again, spiky at the very beginning, but there'll be a long phase where the market growth will be 20 to 30% during the phase where companies are doing the proof of concepts. They're buying individual licenses. They're not buying en masse. but healthy growth rates, but small markets. And then for a lot of the rest of the stuff, the middleware, platform technology, things like that, we're still talking about growth rates in the teens.
Do you see differences across regions as well of these adoption rates? Are there certain regions or industries that are leading the transformation?
Absolutely. In Western Europe, here today at the Hanover Fair, we're at the epicenter of SDA. Let me just state that all of the companies that have a say in the development are represented here. This is where the future of engineering technology is typically created and invented. North America will be a big adopter of the technology because North America has a very seeded tradition in software. When I think of Siemens PLM, where that all came from, it's all the Americans that are great at software and industrial software in particular. In Asia, to a lesser and a greater degree, to a lesser degree in selected markets, like I mentioned, electronics, to a greater degree in places like China, because you have a lot of cases of the state driving it. You have a lot of greenfields. I mean, here I don't see any greenfields out there. It's all brownfields here. But in China, you have just factories being built left and right. And you have the opportunity to start with a clean slate, start new. And the state's saying you got to use digitalization technology as much as it's available.
And are there any key macroeconomic or structural drivers that are behind this shift? Maybe like labor shortages or companies looking for greater resilience, or just productivity pressure, trying to do more with less?
It's a number of factors. You mentioned labor scarcity. I like to talk about skill shifts or skills wandering from industry to industry that make themselves more attractive. That the high cost of capital is also one reason to invest in infrastructure that is more flexible through software-defined architectures. It lowers my initial capital costs, and it spreads my operating costs out over many years. And then just one general thing that I like to observe is system complexity. I work with machine builders in different in different ways, and I see the architectures and how they've grown to become these spaghetti systems. I mean, we have multiple controllers. We have things that architectures that don't make sense sometimes, but they make sense because through necessity. It was necessary to use a different controller to achieve certain servo axis performance that wasn't available like we thought it was initially. And then these systems come together. Anything software defined, putting everything to a big software pot and mixing it up, that's a great way to reduce complexity. It puts all the applications next to each other. It treats them as workloads, which is one of my favorite new words of the year. We borrow from IT, and we treat everything as a living and breathing asset whose resources we need to manage. And applications that by necessity you might have to move to another platform, which you can do seamlessly without interrupting it. But this is the sort of like dynamic world of software management that we're inheriting from the IT world. And that helps to reduce and control system complexity.
So then, Rainer, does this reflect what you're seeing in customer demand and real world projects and sort of the conversations that you're having? Where are you seeing the strongest pull today?
I agree with what David said. Maybe to add on, maybe two aspects. I see beside the electronic topic and automotive, which is always kind of front running, the topic of logistic and intralogistic, currently a field which is very dynamic. And we had here on the fair, Kion is one of the key customers, really want to push the limits what's possible. And I think they can automate more. I mean, that's really a big return of invest. So I think here is the area. And we have another topic here in the booth, which I also like, a new factory concept, because when David talked about greenfield in China, well, they built big greenfields, that's right. What I see, and I like here, the topic of pop-up factories. So it's not a kind of a classical big factory. It might a small one, which might you also tear down if it's not needed anymore. So there are more kind of smaller size factory. We have some great examples. A company called Desert Control, which puts containers somewhere remotely in the world to produce clay for better agriculture. We have here PepsiCo with Gatorade with a pop-up factory. But also like 2 years ago, 3 years ago, we talked about controlled environment farming, which is somehow agriculture as a factory. And you can all that make that kind of much more compressed, and you can produce very close to the consumption. And we see that kind of small size factory, whether it's pop-up or it's whatever in like vertical farming, they normally adapt into new technologies already. Because, like, take desert control, they produce thousands of containers they deploy in the world, and they want to manage those containers centrally. So the workload is there, they update it, they have a new recipe and so on, and they want to manage it centrally. And I think their SDA is a perfect platform to do that.
It's interesting that you mentioned the pop-up factory concept. I think it's such a cool idea that, about putting a factory right where demand is. And yeah, it makes sense that you mentioned earlier, David, about greenfields versus brownfields. And I mean, a pop-up factory to me seems like it's greenfield almost on steroids. It's this little, very highly automated modular factory. Yeah, so I suppose it makes sense that they would be so willing to adopt a new technology. But so as we think about the move towards software-defined automation as well, David, and we talked a little bit about how it might change the strategic approach of companies. And I'm wondering if you could comment on how it might shift the balance between CapEx versus OpEx for these companies as they start to maybe plan out new facilities.
SDA definitely causes a shift between CapEx, so it's from CapEx to OpEx for some obvious reasons. CapEx means I buy my whole PLC system on day one and pay for it, and then I amortize that over the 15 years of lifetime of the asset. I still have to buy IOs, I still have to buy operator panels, I still have to buy all those drives and the electrical cabinets and everything, so I have these capital costs up front. But for the control system alone, I'm putting it onto a server now. There's a good chance that server might have been purchased already. There's a good chance that I have a data center that has capacity to add additional control units in containers. So I might have no capital cost for that, or I might have the cost of one server, but I can take multiple virtual PLCs and put them all onto one server. I haven't done this yet, but I personally might be happy with 3 or 4. When I think of what would happen if somebody kicks the plug out of the wall, but the rule of thumb that's emerging is like around 10 or 12 PLCs, virtual PLCs on a server is you don't want to do more than that probably, but with hardware developments changing and capabilities growing over time, who knows? But my point is that I'm sharing hardware, so it's a common platform. I'm sharing it with other PLCs and with other critical applications as well. So my upfront costs are probably going to be a bit lower. The OpEx costs are going to go up for a couple of reasons. I'm paying licenses. Right now, the rule of thumb is a virtual PLC per year costs about €1,000 or so, roundabout. So I'm basically amortizing the cost of the control over 15 years, 15,000, or whatever it is, 7 years, 7,000 as a rule of thumb. And my engineering and maintenance costs are shifting as well. Previously, in my operational years, I was doing a lot of intervention maintenance. I was going in with my screwdriver, my voltmeter to find out where there's a short circuit or why an I/O module failed. I'm checking voltages. That's shifting to a more software-centric maintenance. I'm sitting at a computer somewhere and I'm monitoring my containers, and I'm getting a lot more information back on the status and the health of these devices, because that's what software-defined automation, that's what virtualization allows. So I'm going to say that the maintenance costs of the pure automation hardware are going to go down. They're going to still be there, but my OpEx costs will actually decrease in terms of maintenance.
It really does always seem to be a balance of how businesses prioritize needs and spend budget. But this is a really interesting example with a focus on how maintenance is priced out. There is still more to come from this great conversation in part 3, so we hope to have you back to hear from Rainer and David again. But until then, be sure to check out our other episodes of the podcast to learn about the different facets of digitalization or how other industries are moving along their journeys. Thanks for joining us, and see you next time.